Hey everyone, in assignment 30, we're looking at simplifying rational expressions. And whenever we talk about rational expressions, it's a good time to come back and talk about domain. So we'll have a little conversation about domain as well. In fact, why don't we start with a conversation about domain? So y equals x squared plus 2x minus 5. Okay, so what's the domain of this polynomial? Is there any restriction on what x value I can plug in here? Come on, think about it. Can you plug in a 0? Sure, I get -5. Can you plug in a 1? Sure, I get -2. Can you plug in -5? Sure. -5 squared is 25, minus 5 times 2 is -10, 25 minus 10 is 15, minus 5 is 10. So sure, I can plug those in. Well, so my question is, are there any points that you can't plug in? Well, no, I guess I can plug all the points in. And that's why the domain for any polynomial function is -infinity to infinity. In fact, we only talked about two types of function that had restricted domains. One is square root of x, where the domain is from 0 to infinity. And the other is 1 over x, where we can't have a 0 in the denominator. And so we say -infinity to 0, union 0 to infinity. This 0 is included. The square root of 0 is 0. But this 0 is not included because 1 over 0 is undefined. Okay? So we said before that we want to set the stuff under the radical, which is called the radicand, greater than or equal to 0 in this situation. And here we want to set the denominator not equal to 0. Okay? Those are our two restrictions that we need to be considering. So let's consider them. All right. There we go. So let's look at y equals 3 over x plus 2. Okay, what can't I have in the denominator? X plus 2 can't be equal to 0, which means that x can't be equal to -2. X can't be that number. Well, it can be all of these numbers, and it can be all of these numbers. So I'm going to say -infinity to -2, union -2 to infinity is the domain for this function. What about this one? 3x minus 1 over 5x minus 2. Will you find the domain for that? Don't forget we write domain in interval notation. Okay, so hopefully you said this can't be equal to 0. So 5x can't be equal to 2, so x can't be 2/5. Here's 2/5. That's what x can't be. X can be all of these and all of these. So -infinity to 2/5, union 2/5 to infinity. Ta-da! Excellent. Well, what about this situation? Y equals x plus 2 over x squared minus 9. What's my domain in this problem? Well, I agree. I'm going to say that x squared minus 9 can't equal 0 and that x squared can't equal 9. But when I take the square root of both sides, what am I supposed to remember? That's right, plus or minus. And the square root of 9 is 3. So this is what x can't be. Can't be -3, can't be +3. It can be these, and it can be these. That's what students usually write. They say -3 to, -infinity to negative 3, union 3 to infinity. And that's, I think, because students so often write that, that's why I like showing the number line version. Because look, x can be these numbers as well. It's just this number and this number that we can't be. So there's another union here with negative 3 to 3 on it. Okay, that's the domain for this function. So you might want to draw out the number line, show what x can't be so that you can see all the places x can be, and then describe them with interval notation. All right, how about the domain here? Y equals square root of x minus 5. Well, we know that x minus 5 has to be greater than or equal to 0, where x is greater than or equal to 5. On a number line, here's 5, could be equal to, could be greater than. And so that's my domain as a number line representation. In interval notation, you'd write this. Okay, so why don't you do this one? Square root of 2x plus 3. Please find the domain here. Come back when you're done, or if you get stuck and need help. So did you say the radicand 2x plus 3 has to be greater than or equal to 0? So 2x is greater than or equal to negative 3, or x is greater than or equal to negative 3 halves? Because that's what I did. There's negative 3 halves. It could be equal to, and we want the x values that are greater than that. Well, you know, if I'm not sure on which side to go, I could always test points in this original inequality. If I plug in a negative 2, 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. Is negative 1 greater than or equal to 0? No. What if I plug in a 0? 2 times 0 is 0. 0 plus 3 is 3. Is 3 greater than or equal to 0? Yes. And so, just like we did when we were doing inequalities before, we can use this number line to test values in our inequality to see that our domain should be negative 3 halves to infinity. Great. How about this one? Square root of 5 minus x. Now it's similar to the one we did before. That was x minus 5, but this is 5 minus x. So, what are we supposed to do here? Well, I want to say 5 minus x is greater than or equal to 0. And then I'm going to add x to both sides. And I'm going to get that 5 is greater than or equal to x. Or if I read it this direction, x is less than or equal to 5. So let's think about what this would be on a number line. Here's 5. Could be equal to 5, but it's also x is less than 5. I should be going over here. Again, if I'm not sure, I could plug in some values, like 0 and 10. So if I plug in a 0, is 5 greater than or equal to 0? Sure. If I plug in a 10, is 5 greater than or equal to 10? No way. Yes, over here. And so how do we write that domain? Well, remember we always start with the smallest value, that's negative infinity, and go to the highest. And so there's our answer. All right, last domain question. Square root x squared minus 5x plus 6. Actually, minus 6. What's the domain for this function? Well, I said x squared minus 5x minus 6 greater than or equal to 0. Do not add 6 to both sides. You are supposed to factor x minus 6, x plus 1. And so I've got some critical values at 6 and negative 1. There's negative 1, there's 6. And let's plug some test values into this original inequality. Negative 2, 0, and 10. Negative 2 squared is positive 4. Negative 2 times negative 5 is positive 10. So 14 minus 6, which is 8, that's a positive number, so that's greater than 0, so that's a yes. And if I plug in a 0, this goes away, I have negative 6 is greater than or equal to 0, and that's just not true. And if I plug in a 10, 100 minus 50 is 50, 50 minus 6 is 44, 44 is greater than 0, so that's a yes. And the points themselves, well, if we test them, they can be yeses as well, because yes, we can be equal to. And so then my domain here would be negative infinity to negative 1, union 6 to infinity. I know these are brackets because when I test these points, I get yeses. Remember always to start with the smallest value and go larger. Okay, so there's our review of domain. Now let's move on to simplifying rational expressions. And you've had a lot of practice with this. I like to think you'll be pretty comfortable with this. But factoring will be important in doing this work. All right, so let's start off with 3xy over xy plus x. Do you see any factoring? Sure, I do. Oh, by the way, see these? Yeah, you can't cancel them. Why not? Because this doesn't also have an xy. What you can do on the denominator is factor out an x. X divided by x is not 0. X divided by x is 1. I need to be able to distribute this and get back to this. On top, we have 3xy. And now I see that I can cancel out x. And so my simplified answer is y over y plus 1. Okay, I can't cancel that out, can't cancel that out. I know I'm canceling an x later, but that's because I factored an x out of all of the terms. If I can take it from all of the terms, that's when I can cancel it out. Not when I can only take it from some of the terms. Okay? All right, how about this one? 4y minus 8y squared over 10y minus 5. Okay, again, don't cancel those y's. These things aren't attached with multiplication. If these things were attached with multiplication instead of addition or subtraction, well, then yeah, I agree with you. I would be canceling, but I don't have that situation here. This is 4y squared, not 4y. But I do notice that I can take a y out of each of these and a 4 out of each of these. So what's left over from 4y if I divide by 4y? 4y divided by 4y is 1. And what's left over here when I take 8y squared and divide it by 4y? 8 divided by 4 is 2, and y squared divided by y is y to the first. On the bottom, do you see anything you can factor out? I could factor out a 5, and then I'd have 2y minus 1. But wait, this is negative 2y, and this is positive 2y, and this is positive 1, and this is negative 1. They're not quite the same yet. So instead of just factoring out a 5 from the bottom, if I took a negative 5 out, then this would be a minus, and this would be a plus, and then these would be the same. So negative 4/5 y, or negative 4y over 5, or 4y over negative 5. Any of those answers is fine for this problem. So, like I said, factoring is kind of hard. How about this one? X minus 5 over 10 minus 2x. Will you try simplifying that rational expression? Okay, welcome back. I hope you didn't cancel out those x's. What did you do? That's what I want to know. What did you do? Did you notice that on the bottom you could factor out a negative 2? Well, let's factor out a negative 2 and see what we get. I take out a negative 2 on the bottom. 10 divided by negative 2 is negative 5. Negative 2x divided by negative 2 is positive 1x. And on the top, we have x minus 5. You'll notice that's minus 5 and plus x and plus x. These are the same. X minus 5 and negative 2, x minus 5. In this situation, I can cancel those. My answer is not 2, negative 2. This is in the denominator. It's 1 over negative 2, or negative 1/2. Okay? Now, we're not solving equations here, right? So we don't have to worry about this being a must-check situation. Right? We don't have to worry about that here. Instead, all we need to do is simplify the expression. Okay? So all we're doing is simplifying the expression. So, how about simplifying this expression? Y squared minus 7y plus 12 over y squared plus 3y minus 18. So what can we do here? Alright, so if I factor the numerator, I have y minus 3 times y minus 4. And if I factor the denominator, I have y minus 3 and y plus 6. Okay, now what? That's right, cancel those out. And so our simplified version is y minus 4 over y plus 6. Please do not cancel these y's out. You cannot cancel those y's. Don't cancel those y's. Don't cancel those y's. And no, I haven't said it enough times yet because people are still going to want to cancel those y's. So stop canceling those y's. Don't cancel the y's. Please don't cancel those y's. All right, so that's simplifying rational expressions. Now we've also got multiplying rational expressions. What does multiplying look like? Well, if I have r over r minus 1 times r squared minus 1 over r squared, the first thing I think about is still factoring. R times r minus 1, r plus 1 over r minus 1 times r squared. Well, these can cancel, and one of these can cancel one of those, so I get r plus 1 over r. All we have to do is factor and cancel out the factors. That multiplication symbol just says that we've only got one term here. It's not about common denominators. Common denominators is for when you need to add and subtract these fraction things. We're not adding and subtracting, we're multiplying. Okay, so when I have x squared minus x minus 6 over x squared plus 6x plus 9 times x plus 3 over x squared minus 4. The first thing I do is not cancel those out. No, I'm not going to cancel that 3 with that 9. No, I have to factor these things. Factors are the things that I can cancel out. Luckily, you've had a lot of practice factoring. There's an x plus 3, and there's an x minus 2, and x plus 2. So what can be cancelled? Well, I can take that and that, and I can take that with one of those. So I'm going to end up with x minus 3 on the top, and x plus 3, x minus 2 on the bottom. And no, I would not FOIL that out. The reason being that when we see it, when you see it this way and when I see it this way, both you and I know there's no more canceling that can happen. Okay? So leave your answer in factored simplified form like this. Alright, how about this one? How about x squared plus xy plus minus 2y squared minus 2y squared over x to the third plus x squared y times x over x squared plus 3xy plus 2y squared. Alright, will you please go simplify this expression? Welcome back. You know, some people get stuck trying to factor this trinomial. They're okay saying x times x equals x squared. They really get stuck with this. And so I know there's a y and a y, and to make negative 2, I need a minus 2 and a plus 1, or I need a minus 1 and a plus 2. Okay, so that's what I'm not sure about. If I FOIL, I get plus 1xy minus 2xy plus 1xy minus 2xy is going to be minus 1xy. Well, we need a plus 1xy, so I need to change the signs of this. This is going to be plus, this is going to be minus. Well, let's check. X times x is x squared. X times 2y will be 2xy. Minus y times x is minus xy. And then negative y times positive 2y is minus 2x squared. So these combine to make 1. Great, yeah, that's it. So that's how I factor that one. On the bottom, I can GCF factor an x squared out, leaving me x plus y. Okay, what about over here? Well, here I have an x, and then there I have another trinomial to factor. That factors as x plus 2y and x plus 1y. So what canceling do we have? Well, these can go, and I can take one of these and one of these. But I don't see anything else. This is a minus and these are pluses. We have x minus y on the top, and on the bottom, x times x plus y squared, because one of them times one of them. Alright, so that's multiplying rational expressions. Next, let's take a look at dividing rational expressions. What did your teacher say when they gave you 18 over 24 divided by 3x? Well, remember, when dividing fractions, we flip the second term and multiply. So we're still going to have 18 over 24. That one doesn't change, but the second term flips and we change to multiplication. And then we can do our canceling. And I get 1. That's pretty much what we're doing here with these rational expressions. It's just that they're going to have some algebra stuff in them. So how about x squared minus 16 over 5x plus 10 divided by x plus 4 over 5x squared minus 20. Well, the first thing I do when I see one of these problems is flip and multiply. Will you please finish simplifying this expression? Okay, so did you factor? You get x minus 4, x plus 4, and 5 times x plus 2 times 5 times. That's, when I pull out the 5, I've got x squared minus 4, but x squared minus 4 is a difference of squares, and so I've got x minus 2, x plus 2, all over that x plus 4. Okay, so there's x plus 4's cancel, x plus 2 cancels, and I can cancel a 5. And so I'm left with x minus 4, x minus 2. That's my answer when I divide this rational expression by this one. Alright, how about you do one? How about x squared minus 14x plus 49 over x squared minus 49 divided by 3x minus 21 over x plus 7. Give that one a try. I agree. I would definitely flip and multiply. But then I need to factor. This factors as x minus 7, x minus 7. This is a difference of squares, x minus 7, x plus 7, times x plus 7, and I can factor out a 3 here and have x minus 7. These cancel, these cancel, these cancel. All I have left is a 1 on top and a 3 on the bottom. Well, that's pretty elegant. Okay, so we've done simplifying, we've done multiplying, we've done dividing rational expressions, and now it's time to add or subtract rational expressions. And with adding and subtracting, just like with fractions in middle school, we need to make a common denominator. Now, when we were doing the solving stuff in the Algebra Basics unit, I said that whenever I had a fraction, I wanted to multiply all the terms by the least common denominator to get rid of all the fractions. Yeah, I can't do that here, because these aren't equations. These are rational expressions. There's no equal sign in them. I'm not supposed to get x equals some number. All I'm supposed to do is simplify the expression, which means I have to make a common denominator in these situations. Okay, so 3 over x plus 2 plus 4 over x plus 5. Now, that's a thing, and that's a thing, and these things are not common to those fractions. So I need to multiply over here by x plus 5 over x plus 5. And I need to multiply over here by x plus 2 over x plus 2. Now, see the way that I've done that? X plus 5 over x plus 5, a number divided by itself, is 1. I'm not changing the value of this fraction if I multiply top and bottom by the same amount, because I'm multiplying by 1. What I see a lot of people write down on their paper is this. And this is not correct. This does not make a common denominator. This is bad. Okay, it's got to be top and bottom. Okay, and remember, this number has to get distributed to both of these. This number has to be distributed to both of these. Most students who don't use parentheses only do part of the distributing. So now we've got a common denominator, x plus 5, x plus 2. On top, 3x plus 15 plus 4x plus 8. Don't forget to distribute. And then if I combine like terms in the numerator, 7x plus 23 over x plus 5, x plus 2. All right, I'm done. Hey, always check to see if there's any factoring you could do here, because maybe there'd be some more canceling. So we have to make a common denominator and then add or subtract as the sign says. So in this situation, 3 over x minus 2 plus 5 over 2 minus x. Now, I think it would be really nifty cool if you recognized that that was a positive and that was a negative, that that was a negative and that was a positive. The signs are flipped. Well, to get them to be the same sign, all I need to do is factor out a negative, right? Because factoring is dividing. If I divide that by negative 1, now I have negative 2. If I divide negative x by negative 1, I get positive x. So I'm going to divide out that negative, which means I can now write this as 3 over x minus 2 minus 5 over x minus 2. So 3 minus 5 is negative 2 over x minus 2. I swear if you cancel these out, I will chase you with a pool noodle to the ends of the earth. Okay, you cannot cancel those. Stop it. Okay, so there's my simplified rational expression. How about this one? 2 over x squared minus 4 minus 1 over x squared minus 3x plus 2. Well, if I factor, I see x minus 2, x plus 2, And if I factor, I have x minus 2 and x minus 1. I have x minus 2 and x minus 1. Our common denominator is what they have in common and anything they don't have in common. That's going to be my common denominator. Well, this has these two, it needs that one. So I'm going to multiply top and bottom by x minus 1 over x minus 1. I'm putting the parentheses so that I remember I'll need to distribute them. This fraction has this one and so it needs an x plus 2. So I'm going to multiply top and bottom by x plus 2. Alright, so what do I have? Well, that's my common denominator, one of what they have the same, and everything that they don't have the same. Now I have to do that distributing I mentioned earlier on top. Oops, minus 2. Now we have a minus 1 times x and a minus 1 times 2. So when we combine these, what do we get? Well, 2x minus x is x, minus 2 is minus 4 over x minus 2, x plus 2, and x minus 1. And there's our simplified version. All right, let's try one more of those. 1 over x squared minus x minus 2 minus x over x squared minus 5x plus 6. Will you please simplify that rational expression? That's right, we have to start with factoring. X minus 2, x plus 1, x minus 2, x minus 3. So remember, my common denominator has one of what they have in common and one of all the things they don't have in common. That's the common denominator. So this one has these two, and it needs that. And this one has these two, so it needs that. So what am I going to get up top? I'm going to have x minus 3, negative x times x is negative x squared, and negative x times 1 is negative x. I can combine some like terms here. Oh, negative x plus x. Well, they go away. And, you know, while I could take a negative 1 out on top, I don't see that that's really going to help me because there's not going to be any canceling. So I think I'd leave it just like that. Okay, so there we go. Simplifying rational expressions, multiplying and dividing rational expressions, adding and subtracting rational expressions. The last thing I want to ask you to do is, could you show me the expression that represents the shaded area? Okay, and I'm going to give you some information. I'm going to say that this is 3x plus 1, and that this is 2x minus 3, and I'm going to say that this piece up here is x plus 3 over 2, and this over here is x plus 1 over 2. Okay, so how do I find that shaded area? Think about that, and come back when you're done, or if you get stuck thinking about it. Well, so I see two rectangles here. I see this big rectangle on the outside, and its area is length times width, 3x plus 1 times 2x minus 3. But I also see this little rectangle here, whose area is going to be x plus 2 over 2 times x plus 1 over 2. And what I need to do in order to get the shaded area is take the big red one and subtract the little blue one. So I find that that's going to be made easier if I FOIL this out. 6x squared plus 2 minus 9 is minus 7x minus 3. And here when I FOIL, I get x squared plus 3x plus 2 over 2 times 2 is 4. All right. Well, that's a little hard for me to combine like terms on that. But doesn't mean I can't. 6x squared minus 7x minus 3. And I'm subtracting the blue one, which is 1/4 x squared plus 3/4 x. And 2/4 is 1/2. Wait, how did I know to do that? Well, I split this up into 1, 2, 3 fractions. That's what you see there. So that I could do 6x squared minus 1/4 of an x squared and get 23/4x squared. And then here I have a minus, I think that's minus 7x. Yes, because it was minus 9x plus 2x. Okay, so minus 7 minus 3/4 is going to be minus 31/4. And then 3 minus 1/2 is going to be minus 7/2. All right. Well, I hope you feel well reviewed with working with rational expressions and domain. And let's watch the next video where we talk about complex fractions. Remember to ask questions. Do the homework. Write down what questions you get stuck on so you can ask questions. Please. All right.